All right. In his best-selling 2014 book, Homo Sapiens, Yuval Noah Harari discusses a history of humankind. And one of the most important ideas at the core of this book is the importance of words, the importance of stories. Words and stories and language are the master key that unlocked our potential as human beings. Whether it's your religion, your nationality, or the company that you work for and the vision that that company has. Our ability to communicate an idea, to get people behind an idea, is fundamental to what has made us so successful. Now, I can see some of you furiously checking the agenda, thinking this was going to be a talk about event-driven architecture. Why are we talking about a history of humankind? But there's a link here, and that link is that event-driven architecture is fundamentally a communication pattern. It's a way of modeling integrations between systems, whether that be the technical communication between two services or the human communication when it is you're talking about what it is that your system does. And that's what you're going to learn about in this talk. You're going to learn some of the secrets of event-driven architecture, some basic concepts through to some more advanced patterns that you can use and take away. I'm James Eastham. I'm a serverless developer advocate at Datadog. And I want to start off just by saying this is not going to be a talk about a specific programming language, a specific technology, a specific messaging provider. This is a really simple talk that's simply about boxes and lines. Yeah, it's one of those kind of talks. And I actually want to start Copenhagen being very, very honest with you all as we get started. I've built event-driven systems in the past. I've built small systems, big systems, good systems. I've built an awful lot more bad systems. Systems that have failed really, really badly. And how many of you have ever done something or built something that has failed? Don't worry, it's a safe space. Okay, those of you with your hands down, can you come and find me afterwards? I want to know what the heck it is that you're building. And that's a really odd way to start a talk, right? Talking about failures. But I'm sure all of you who built something that failed, you learned so much more in that failure than you did when you built and deployed the thing that just worked. So that's what I want to try and share with you, some of the pitfalls, some of the problems I've encountered. And there's something I love talking about almost as much as serverless and event-driven architecture, and that is pizza. Who here loves pizza, by the way? Just a quick show of hands. Okay, those of you with your hands down, what? So for the rest of this talk, you're all now going to be developers for a completely fictional pizza delivery company called Plant-Based Pizza. And this is your architecture today. You've already adopted microservices, you've got good reasons for doing that, and you've prioritized synchronous communication. So you've got this order processing service right at the core here. That's kind of the most fundamental part. If people can't order pizzas, then, well, you're not really a very good pizza restaurant, are you? But this order processing service has these really explicit dependencies to all these other services, and now you need to go and add a new loyalty point service. And to do that, you need to go and make a change to the order processing service to make all that work. And what you're dealing with here is a form of coupling. Synchronous communication gives you more tightly coupled systems. And I'm sure some of you will have heard the general rule of thumb in software development, which is that you should aim for low coupling and high cohesion. Now, cohesion is a relatively straightforward one. The idea of cohesion is that things that change together should live together. And you've already kind of got that building microservices architectures, because the features, the functionality that are going to change together are deployed as an independent unit. But coupling is a slightly more tricky one. Coupling is tricky because there's lots of different types of coupling that you might see. You've got technology coupling. Are you using Java, C++, REST, gRPC, GraphQL? You've got data format, semantic coupling. How do you handle null values? Are you using binary, JSON, protobuf? What kind of casing are you using for your property names? And then you've got things like location and runtime and temporal coupling. That's primarily what you're dealing with when you build systems that prioritize synchronous communication. At the point your system is running, it needs to know the location of all the other services it needs to talk to at that moment in time. And coupling isn't all bad, because if you built systems that were completely decoupled, well, it'd be really hard to get any meaningful work done. And there's an appropriate level of coupling to aim for. And that level depends on the amount of control you have over the endpoints. I love this quote from Gregor. If you're not familiar with Gregor's work, he wrote Enterprise Integration Patterns, which is a really fantastic book about some of these concepts. And what I think Gregor means by this quote is that if you're working on a team that maybe owns 3 different services, coupling them services together more tightly isn't necessarily a bad thing, because you control the backlog, you control the SLAs, you control the on-call, you control all of that stuff, and it's okay. But once you start integrating with something outside of your control, whether that be a third-party API or maybe another service inside your organization, you want to look to reduce that coupling as much as possible. So if it's coupling that we're dealing with, coupling is the challenge that we're trying to solve for, why does it actually help to be event-driven? So let's come back to this use case that you've got. You need to add this new loyalty point service. And to add that loyalty point service, at the moment, you need to go and make a change to the order processing service. So you might go off, you might build your loyalty point service, it's fantastic, you deploy it, and then you're stuck in the backlog of the order processing service waiting for them to call your service. And when you think about that point of integration. Is it really right? Should the order processing service even care about the fact that people are collecting loyalty points? Now, I would argue no, because it's not its responsibility. But there's another challenge here as well. If you're prioritizing this synchronous communication that needs this runtime, this temporal, this location coupling, a failure in one of your services, and this might be a service that's not on the critical path of your application. If people can't collect loyalty points, I'm sure they won't mind as long as they still get the pizza that they ordered in the first place. But having this synchronous communication can have the knock-on effect of causing maybe more critical systems to go down, these cascading failures across multiple services. So this is another challenge that you have to deal with. And this is your responsibility as a developer of the order processing service to care about the constraints of a system that you don't even control. I realize I'm massively oversimplifying that. I realize there are ways to build synchronous microservices that deal with some of these challenges. Circuit breakers, exponential backoff, proper error handling. But that means that's your responsibility for the constraints of a system you don't control. And this is where event-driven architecture can help you. So before we get into the practical stuff, let's just get some level set on some of these terms. What does it actually mean to be event-driven? And one of the best definitions I've found for this is taken from one of Martin Fowler's talks about event-driven architecture. And at its core, an event-driven system simply reverses the lines of dependency. It reverses these lines of integration. So instead of your order processing service needing to know about the loyalty point service or the kitchen service, instead all these services are simply reacting to events that the order processing service is publishing. So you've flipped that line of dependency around. So if that is what it means to be event-driven at its core, what actually is an event? An event is an immutable fact. It's something that has happened in the past. It's something that cannot be changed. So I want you to imagine it's the middle of winter here in Copenhagen. I imagine it's quite dark all the time if it's anything like the UK. And you get up, and you're in your house, and you need to do something meaningful in your house. And you want to get from one side of a room to the other, and there's plugs, and there's Lego bricks, and there's all this kind of stuff lying around. And of course, you don't want to stand on any of that stuff, because that's going to really hurt. So you're going to go over to the light switch, and you're going to hit the light switch. That's going to raise a light switched on event. It is irrefutable that the light switched on. You can't unswitched on a light. That has happened. It's on. Once you're done doing what you need to do, then you're going to hit that light switched again. That's going to raise a light switched off event. Then you're back to dodging Lego bricks on the floor. The light switched on, the light switched off. It is irrefutable. Then things have happened. So if that's an event, what does it mean to be event-driven? And I sometimes think this gets a little bit confused with what I'd call an event-based system. So you've got event-driven systems, you've got event-based systems, and there's a really important distinction between the two. An event-driven system drives business functionality using business events. We've been using events in systems for years. I started out building Windows Forms applications in .NET. Things happened when buttons were clicked. when windows were resized, when your mouse hovered. These are all events. But that's what I'd call an event-based systems. These are technical events, not business events. Business events are things like these. Order boxed, order completed, staff member clocked in. You could look at two systems in the exact same domain for two different companies, and they would probably have a completely different set of events. But they're probably going to have things that are similar. Buttons are going to be clicked. Files are going to be uploaded to cloud storage. So this is a really important distinction to make. It's important because an event-driven architecture lets you tell the story of your business through its technical implementation. The language of your business comes into the software itself. So something else you'll often hear about event-driven architecture is that events are first-class citizens in your system. That sounds a little bit buzzwordy, doesn't it? First-class citizens. What does that even mean? So how many of you are familiar with the idea of API-first design? Heard the term before? Okay, about half of you. Cool. If you're not familiar, the idea of API-first design is that the first thing you do before you write a single line of code is to design the API. Imagine you've got a front-end team and a back-end team. You want to do something together. You're going to design that API first. Both teams can go off, work independently, work asynchronously, and then you bring it all back together at the end. And in an event-driven system, your events are your API. So making events first-class citizens means that you practice event-first design. The first thing you're going to do when you start building an event-driven system is actually design your events, work out what your events actually are. And some of you might be thinking now, you've heard the term events, you've also heard the term messages. What's the difference? Do I use events or do I use messages? When actually, events are messages. Events are a type of message. And typically there's three different types of messages you will see in a system. You'll see commands, you'll see events, you'll see queries. Now commands and events are very similar. The difference between a command and an event is mostly just a statement of intent. Am I telling a system to do something, which would be a command? Or am I telling a system that something has happened in my system? That would be an event and someone else can react to it. And then, of course, queries are nice and easy. Queries is just me asking for a specific piece of data, getting some information from somewhere. So at this top level, you've got messages, you've got events, commands, and queries. Inside events, you've got a few different types of events. Events aren't just these random pieces of JSON data that you just start publishing and don't really think about. There's different types of events. The first of which is a notification event, sometimes known as a thin event. A really small, really simple packet of data that simply just notifies another system that something has happened. And this is where you start with your implementation at the pizza restaurant. You start with this point of integration here between the order service and the kitchen service. You think we're going to take that synchronous bit of communication and we're going to make that event-driven. So your order service starts publishing this order confirmed event, and your kitchen service consumes that event. Nice and simple, right? The kitchen service consumes the event, it has a look at the event, and the event only contains an order ID. That's it. This is a notification event. It's really thin, remember. So what does the kitchen service do? How does the kitchen service know what exactly it needs to put on this order? So it thinks, well, I can just make a callback. I can just make a callback to my order processing service to get more information about the order. Yay, we're event-driven, woohoo! But actually, this isn't really any better off, is it? Because we had a synchronous line of communication going from order service to kitchen service, and we've still got that, it's just now the other way around. So we're not really any better off doing this. There's another challenge here, though. Now that you're publishing these events, you open up the potential for other services to access them. So maybe one other service starts accessing this event, starts making a callback. And then 3 more services do. And then another service. Then a couple more services. And then suddenly, before you know it, everything's on fire because all these services that you didn't even know about are all calling back to your system and overloading your system. One of the common things you'll hear in event-driven systems is that services are unaware of the downstream consumers of their events. And whilst this is technically true, you probably should care about what downstream systems might do with the event that they receive. So how do we solve for this? How do we get around this challenge of needing callbacks, needing systems to call back and get more information? Which leads us nicely onto a second type of events that you'll commonly see, which is the idea of event-carried state transfer, otherwise sometimes known as a thicker event or a fat event. So if we take that order confirmed event, this is what it looked like, just an order ID, and this is what meant we needed to make the callback. This same event as a thicker event would look something like this. You'll notice now the state of the order is being carried as part of the event. So now as a developer of the kitchen service, you're happy now because you received this order confirmed event and you're like, excellent. We've got all the order items. We know exactly what we need to cook. We no longer need that callback, which makes it sound obvious, right? Clearly, the right answer here is always to use thicker events. That's so fast. Because let's look at why that can be a problem. In an event-driven system, there's typically three key components. You've got some kind of producer or a publisher. You've got some kind of consumer or a subscriber, and then you've got some kind of transport mechanism in the middle. That might be an event bus, it might be a queue, it might be a topic, it might be a stream. There's just something in the middle that's transporting these events from place to place. And you'll immediately notice that the producer and the consumer here have no idea that each other exists. There's no line between them directly. This almost immediately removes that runtime, that temporal, that location coupling, which is good. The primary integration pattern at play here is the publish-subscribe integration pattern. A producer publishes an event, and n number of systems can then go off and can subscribe to that event. And the responsibilities of a producer and a consumer get really interesting. As a producer, your responsibility is to stick to that schema you agreed on. You agreed on what an event's going to look like, and you agree to try to stick to that and not make breaking changes wherever possible. Where it gets interesting, though, is the things that you're no longer responsible for as a producer. You are not responsible for what happens to your event after it gets published. When compared to synchronous communication, you're also now not concerned with the constraints of the system that's downstream of you. If you think about building a synchronous communication, you're making a REST API call. You need to care about what rate limit can that system support. How do you secure? What API keys do you need? Is it up? Is it down? Is it fast? Is it slow? You need to think about all them things as a developer. With an event-driven system, these things aren't your responsibility anymore. If you want to publish one event a second, 10 events a second, 100 events a second, that's fine. So that's a really interesting benefit as a producer. Now, as a consumer, you just need to plan and control the ingestion rate. Because remember, these producers now, they don't care how many events they're publishing. So you need to plan for that. You need to control and plan for your own ingestion rate. And one thing I would always recommend you to do in an event-driven system is to subscribe something else to that bus. Don't subscribe your application code directly to the bus or the message channel where these events are being published to. Put some kind of intermediary in the middle, typically a queue. So what's going to happen here is the producer is going to produce an event, the event's going to hit the event bus, and then it's going to filter through into a queue that you control. You're going to then hook your application code up to that queue, which means you can control an ingestion rate that suits you. If you can only handle one message a second, that's absolutely fine. Your queue might start to get really, really big, but at least you're not losing messages, your systems aren't failing and falling over. There's another really subtle benefit of event-driven systems. How many of you have ever tried to build something and you thought the product manager wanted X, and actually they wanted 96,242? Still a safe space. You can still admit if you built the wrong thing, that's okay. Communication is really, really difficult. Language is so important, as we learned at the start. Now that you've got these events, these business events flying around, you can start to have really sensible conversations with people. Instead of talking about REST APIs and microservices, you're now talking about what should happen after an order is placed. What should happen after an order is cancelled. You can have these conversations using a language that everyone understands. Because remember, event-driven architecture is fundamentally a communication pattern. It's a way of modeling integrations between systems. So let's actually start to make this more event-driven now. Let's actually take this core order processing flow. We'll move it from a synchronous-based system to a more asynchronous one. And this is what the flow looks like today. An order comes into the order API. The order API makes that synchronous call to the kitchen. The kitchen's going to go off. It's going to create the order. Once it's done, it's going to make a call back. Order processing service says, yep, I know this order is ready now. I know this order needs to be delivered. Make a call to the delivery service. Delivery service delivers the order. Call comes back. That's been delivered. Finally, call goes out to the new loyalty point service. Loyalty point service responds. And even in this relatively simple architecture, you've still got 6 lines of synchronous communication there. 6 things that are runtime coupled, that are temporally coupled, that need to exist for this system to work. So let's actually go about and make this event-driven now. And if you're in this situation today where you've got all these synchronous calls, the first question you might be asking yourself is, how do I actually understand the events in my system? How do I know what these business events are? And to put this same image back on screen again, there's something in this image that is kind of useful, a technique. And that is the idea of event storming. Who's heard of event storming? Who's actually done event storming? Just keep your hands up. Okay, quite a few of you. Awesome. So the idea of event storming is, if you're not familiar, it was popularized by a guy called Alberto Brandolini. And quoting directly from the website, it is the smartest approach to collaboration beyond siloed boundaries. And the website lists quite a few different scenarios where event storming is really useful, one of which being to design clean and maintainable event-driven software to support rapidly evolving businesses. Sounds nice for us, right? And I do want to point out at this point, these two things don't have to be together. You can build an event-driven system without doing event storming. And event storming is still very, very useful, even if you're not building an event-driven system. So these two things are exclusive. However, they do work really well together because we're talking about events. So this isn't going to be a deep dive on event storming, but just really quickly how this would actually work. You'd get everybody in a room together, technical people, non-technical people, business people, domain experts, all of you in the room together. And this is not a technical session. I can guarantee you every time you do an event storming workshop, there'll be 2 developers in the corner talking about how best to implement this with Kubernetes. The answer to that question is, of course, always don't. Just kidding. But this is not a technical discussion. This is all about the business. This is about understanding this shared language. So everyone's in the room, you're all putting post-it notes on the wall to indicate all of the events that happen in the system. And then you're going to organize these events by time. So then you know, end to end, what events should happen in roughly what order. So now you've got this shared language for all the things that happen. And then you're going to add more post-it notes for the commands that are going to trigger these events. Again, shared language. And for the queries that are needed for them commands to happen. What views do people need to work with? And there's a bit more to it than that. But what you'll commonly end up with is a set of things that look like this. You've got a query. If you imagine you're on a mobile app on your phone trying to order a pizza, the first thing you're going to do is you're going to list all of the pizzas that are available to buy. Then you're going to add one of these pizzas to your basket, a command. And then off the back of that, there's going to be an event that gets triggered, the pizza added to order event. And you're typically going to end up with this repeated over and over again. Query, command, event, query, command, event. Not in all cases, but in most cases. And the benefit of this, again, is to get that shared language. So now everybody in the business knows exactly what the right language is to get the system working in the way it should. So one of the things you'll commonly hear about event-driven architecture, and it was even in that quote from the event storming website, to build rapidly evolving systems. Evolvability is a core benefit of event-driven architecture, right? You've got these events that are just flying around, and any service at any time can just hook into this stream of events, which sounds incredibly evolvable, right? You can add new features, add new functionality without touching a single other part of your architecture. And let's actually think that through now. Let's come back to this same order confirmed event, this thicker event. And remember, you introduced that thicker event to get around that issue of needing a callback. And because you're all doing such a fantastic job building this system, and it's scaling and it's resilient, you now need to go global. Pizza restaurants are opening all over the world. You now need to start supporting multiple currencies, because that value field that's just a decimal isn't all that useful. what currency is that in? So you think, well, we did that event storming thing. It's only the kitchen service that actually cares about this order confirmed event. The kitchen surely doesn't care about the value. I'm just going to make this change to my event. I'm going to change that order value from being a decimal to being an object that has a currency and a value. Anyone see a problem with us doing that? Okay, a few hands. Because although the kitchen service doesn't care, they've just carry on working with the items. At this point, you get an incredibly angry phone call. That angry phone call is from the analytics service. Who knew there was an analytics service? There is now, because you've got this evolvable system. You can add new services at any time, remember? And the analytics service, well, they really, really cared about that order value because they're going to use that. Which doesn't sound particularly evolvable, right? It's also not a good way of making friends, I'll tell you that. So what do we do now? How do we handle this? How can we deal with this scenario? And I'm going to put a really horrible word on screen now. It's a really, really naughty word. Please don't all get up and leave when I do this. Sometimes I find this bit of the talk really even difficult myself. And that word is governance. Yeah. It's awful, isn't it? It makes you feel like bureaucratic and red tape and change approval boards and all that kind of stuff. But it's something that's really important to get right when you're building event-driven systems that use these thicker events. And governance doesn't need to be painful. That's a weird sentence, isn't it? I never thought I'd say that. There's things you can do to make this easier. And you can use a process that some of you are probably already familiar with. That's the idea of a request for comment, or an RFC. Who's familiar with the RFC process, broadly what it does? Okay, cool. It's quite common in open source software. With an RFC, before you make a change to a system, you're first going to write up an RFC about the proposed change that you're going to make. And that then gives other systems, other teams, the ability to comment on the change you're thinking of making. So the kitchen service would see this and they'd be like, yeah, that's fine, don't worry, change that value if you want. The analytics service are going to see it and they're going to say, whoa, please don't do that. That's going to be hard. That's going to be painful. And you can have this conversation, so it allows you to keep your teams asynchronous, keep your teams working independently, while still having an element of collaboration when it's useful. So that's how you can handle things at a more process level. What about at a technical level? How can we handle things actually inside our system, inside the code that we write? And we can actually use this schema, the fact that this schema of the events is the tightest form of coupling, we can use that to our advantage in some ways. You can agree on a consistent schema that every single event across your entire organization is going to have. They're all going to have the same schema. And there's actually a specification that exists to describe this. This is the cloud events specification. It is a defined schema for defining events. And to walk through some of the fields that are in here, you've got this data property down at the bottom. The data property is what's going to contain the actual event payload. So although this top-level schema is the same, inside the data property, you're going to have some very different things. You've then got the data content type. This is a really useful one because it tells a consumer what kind of data to expect inside that data property. Here we're sending JSON. We say application JSON. This could be binary, it could be XML, it could be HTML, maybe. That'd be weird. You've got this expiry time. This is an optional field in the specification, but I always like to include it because it's a useful one. If you are publishing events that might be time sensitive, if you publish an order confirmed event, are people going to wait a day for their pizza? Probably not. So you're probably going to put an expiry time in there so that the kitchen doesn't cook an order that's a day old. You've got the time. This is the time the event was actually published. And then you've got the ID. This ID is a uniquely generated identifier generated by the producer. And this allows your downstream consumers to implement things like idempotency. They can look at this event and say, I've seen event A1234789 before. I can just drop that now. I can ignore that. And then when it comes to this conversation around evolvability, you've got these top two properties here, the source and the detail, or the type. The source is where did this event come from? And I always like to include the environment in here as well. So this is the production orders system. And then you've got the type, and the type tells the consumer exactly what this event is. It's an order completed event or an order created event. And importantly, you've got that version number suffixed on the end. This is what you can use to build more evolvable systems, to evolve your schemas over time. Because today, you might be publishing version 1 of this event. And what you're going to do is when you need to make that breaking change, you're going to start publishing 2 events. You're going to publish version 1 and version 2 at the same time. And it's really important that all the subscribers include the version number in however they subscribe, whatever rules they define, however they define that, they need to include that version number. So you're going to publish version 2. Version 2 is going to be incredibly sad because nobody really cares about it. It's just being published and it's just kind of disappearing. And you're going to set a depreciation date. You're going to set a depreciation date on version 1. A month from now, we're going to stop publishing version 1. And it's really important that you stick to that date. Because if you push that date back, let it slide, suddenly you're supporting 10 different versions of the same event, and this is where this pattern kind of starts to fall down. So you need to be really strong on that depreciation date. Over time, everyone's going to migrate over to version 2. Probably do that an hour before you're due to depreciate it, at least in my experience, that's how teams kind of work. But now you've managed to change that over time. You've managed to evolve your system. You've managed to introduce a breaking change safely. So that brings us back to this question, doesn't it? Thick or thin events? What's the right one to use? And I've gone back and forward on this question so many times, you wouldn't believe it. So I'm not going to give you a concrete answer here. Because, of course, thin events reduce that coupling at the schema level because you're not including data inside the event. It does open up the potential for you to need to make a callback, though. So then you might think, well, thicker events, surely thicker events are better because then we don't need to make these callbacks. But then you have more coupling at the schema level. So you need to have really good governance, there's that word again, governance process. You need to have good change management. You need to have good schema management. So there's a lot more things you need to think about with thicker events, at least at a process level. So maybe long live the thin event. And actually, there's a law in software. We love laws in software, don't we? We love these rules of thumb. Postel's law, sometimes known as the robustness principle, states that you should be liberal in what you accept and be conservative in what you send. The second part of that is the incredibly important bit. Be conservative in what you send. And if you take that to the absolute extreme, obviously you might end up back in this same position again, where you're publishing that order completed event and you're only including the order ID. But as we found earlier, this isn't particularly helpful for consumers. So there's something we can take here from one of the core principles of microservices that can help us. One of the principles of microservices is that each service should own its own data. The order service owns the order data, the delivery service owns the delivery data. So this allows us to start introducing patterns where we can publish these thinner events, but we can just include multiple identifiers. And if you think about this in practice, when you're ordering a pizza on your phone, you're going to log in. That's the first thing you're going to do. So inside your web app, inside your mobile app, somewhere you're going to have a customer ID for the logged in customer. And then the first thing you're going to do if you want this order to be delivered is you're going to add a delivery address. That delivery address is going to be stored by the delivery service. Of course, they own the delivery data. And then when you come to submit the actual order, you can include that customer ID, that delivery address ID, inside that order that gets submitted. And then when you publish that event, you've got the data there. The delivery service can consume that event and say, hey, I know what this delivery address is. I know where I need to send this order to. They can then go off and organize the delivery. There's another pattern here which I always like to point out, which is called the claim check pattern, coupled with what's called an enricher. So the idea of the claim check pattern is simply that when you publish the event, you just store all that additional data in some kind of location on the side. That might be a cache that you put a little API in front of. That might be something like an S3 bucket. But you store that data somewhere else. And then you include in the event that you publish the location of that data. So here we've got /metadata/ an order number. And then when you consume that event as a consumer, you can use an enricher to actually reach out to that metadata location, pull down that additional data, and then you've got this thicker event, but you're not actually passing the entire thin event. The benefit of doing this is that when that callback comes back in, the callback isn't coming back in and affecting that main order processing service. It's affecting something else that's on the side. Again, that might be a cache, that might be an S3 bucket, it might be just something else. So you're protecting your system from that callback. And whichever way you do this, embrace some kind of structured schema pattern. If you're not going to use the cloud event specification, there's another pattern called the metadata data pattern where you break your event into a metadata section and a data section. Just do something that is consistent. That's a really hard thing to add retrospectively, so do it from the start. And something else I've been thinking about a lot recently is this idea of thick in private, thin in public. If you think about that quote from Gregor earlier, the level of coupling depends on the level of control you have over the endpoints. So if you're building them 3 services that you consume, that you own, using thicker events with them services that you own isn't necessarily a bad thing. Because again, you control the release cycles, you control the backlog, you control the on-call, you control all of that stuff. But once you start publishing events that are going to be consumed by a service that you don't control, these public events, you want to try and make them as thin as possible. Distinguishing between private events and public events is a really important thing to do as you build out an event-driven system. So something else you need to do if you're building an event-driven system is to start thinking asynchronous first. Everything becomes asynchronous. And if you're used to making method calls or HTTP requests, this can be quite a paradigm shift. I know it was for me when I first started doing this. And it's a paradigm shift because interesting things can start to happen. As the order service, you're going to publish your order confirmed event. And you know, because of that event storming thing that you did, at some point later, you're going to get an order prepared event or an order ready event. But you can never guarantee that that event's going to come back. Frankly, you can never guarantee that that order confirmed event is even going to get there in the first place. And remember, frankly, you don't care. And this becomes a problem with consistency. Asynchronous systems typically gravitate towards more eventually consistent systems. And there's 2 different types of consistency. There's eventual consistency and there's strong consistency. And to kind of talk you through the difference, I want to talk about the payment part of plant-based pizza. And I know we're just before lunch here, so I'm going to ask you to imagine something now, everyone, and it's going to be really hard, I'm sorry. Unless you're the ones who don't like pizza, then you're going to be okay. I want you to imagine you've just walked into a pizza restaurant. You've placed your order, you've gone in to pick it up. You can smell the pizza, you can see them all being prepared behind the counter, they're being boxed up. It's just a wonderful place to be. And before you take that pizza away, you need to pay for it, don't you? And you've got 2 options when it comes to paying for things. The first option you have is to take out your purse, take out your wallet, take out some krona, hand over that krona, they put that in the till, you get your pizza and off you go. This is a strongly consistent transaction. At the point the transaction happens, you can absolutely guarantee that that transaction has happened because the money's no longer with you, the money is with the pizza restaurant, you get your pizza and you go on your merry way. You've got a second option though, don't you? A more common option nowadays. That's to pay with your credit card. So you tap your credit card, you take the pizza, you walk out, you check your bank statement, and then you think, it must be free pizza Fridays. That's amazing. And then a couple of days later, you check your bank statement again, the pizza's charged you now, and of course, free pizza Fridays doesn't actually exist. Great if it did. That is an eventually consistent transaction. All you're doing when you tap your card is making a theoretical guarantee that at some point in the future, that money is going to move. It's going to move from their bank, your bank, to their bank. It's the same with an event-driven system. You publish an event, and theoretically, at some point later, you should receive an event back based on the flow of the system. And really, there's no way around this. This is a trade-off of an event-driven system. You need to embrace eventual consistency. But this is where you are now. You've built out much of this architecture now. You've started to build out this event-driven system. You've got events flying around. You've removed all of this synchronous coupling. Life's wonderful. And then your business leaders come along. And your business leaders say, you know that loyalty point service that you spent blood, sweat, tears, hours, years building? We're going to get rid of that now. We don't want it. We're just going to buy a SaaS product. We're going to buy an off-the-shelf product. And that off-the-shelf product only supports synchronous calls. It only exposes a REST API. So how do you manage that? Because you've got this wonderful event-driven asynchronous system, then you've got this bit on the side that isn't asynchronous. This same pattern can also apply if you're dealing with legacy systems, if you've got a system that already exists and you need to integrate with that. Because you want to protect against that system, but you don't want to get rid of all this wonderful event-drivenness. And what I always recommend is that you should keep some kind of loyalty point service. Keep some kind of loyalty point service. That service is still going to be event-driven, and that service is going to act as a kind of translation layer. It's going to take the events that come in, translate them to a HTTP call, make the HTTP call, and then maybe publish an event back onto the bus based on the status of the response. But really importantly, you've got a queue in the middle. You've got some kind of durable storage. And that's, again, to protect yourself against these downstream systems that you don't control. Maybe your legacy system can only support one request a second. Okay, having this queue allows you to control that. Having this durability allows you to control that. So if you need to integrate an event-driven system with one that isn't event-driven, still having some kind of event-driven microservice there is really useful, and then that simply acts as a translation layer. This can be a really great way to get started for people who aren't familiar with event-driven systems, because all you're doing is kind of adding this little translation, and you've still got a bit of HTTP knocking around, which people are familiar with. Another topic that's incredibly important in event-driven systems, and there's probably a whole other hour I could talk on about observability in asynchronous systems. This is probably its own talk. But there's something I wanted to point out really today, and that is make sure you include the potential to add distributed tracing to your event-driven systems. If we come back to that cloud event specification again, the specification actually includes a spec for distributed tracing, the trace parent property. And here I'm using an OpenTelemetry compatible trace context, but it doesn't necessarily need to be that. It could simply be a correlation ID. It could be some common identifier that you pass from system to system to system that allows you to understand cause and effect. Cause and effect gets incredibly difficult in event-driven systems because you've no longer got this service that makes a call to this service and you can follow the bytes across the network and see that they've talked to each other. So really early on, think about how you're going to observe this system. How are you going to understand cause and effect? How are you going to, if your system breaks, how are you going to be able to look back upstream and see what might have changed in another system? So the other thing I want to talk about is boundaries. Surely somewhere, somehow, you're going to need synchronous. We've already talked about making synchronous calls out. What about synchronous calls coming in? Maybe your mobile app, maybe your web app. That probably doesn't talk event. So how do you deal with that? A pattern that I'm quite a big fan of is including these really thin synchronous API layers around the edge of your system. So you're going to build this synchronous API, and all this API is responsible for is simply validating the request that comes in, storing that data in a database, and publishing an event onto the event bus. No complex business logic, it's just a validation layer. All the complex business logic is going to happen asynchronously behind the scenes. And if you've ever bought something on Amazon with a card that's expired, you'll have seen this in action. When you place the order on Amazon, you'll have got a thank you for your order screen. Seconds, minutes later, you'll get an email into your inbox saying, can you please go and update your payment method? This is exactly what is happening here. You've got the request coming in, it's being validated up front to give that user that real-time feedback that the order is valid, and then all the actual complex stuff is happening asynchronously behind the scenes. Now, this might make you think, if all the work is happening asynchronously in the background, how does that help the person like me who orders a pizza and sits there furiously refreshing their phone, understanding what the status of my order is? Because all the work is happening asynchronously now. But remember, you've still got events that are flying around. You've still got the kitchen service publishing that order prepared event. And the delivery service might be interested in that because they need to go and deliver the order. But the order service can also be interested in that order prepared event. The order service can consume that order prepared event, and all it's going to do with it is update the status of the order in the database. So me sat there furiously refreshing my app can see that the order is being prepared. It's going to be on its way soon. Asynchronous commands. Can we do commands in an asynchronous way? A common thing you need to do in most software systems is to send emails. Send an email. It's quite a common request. And you might want to break that email sending functionality out into its own microservice. You want to put it behind some kind of abstraction. And of course, a way you could do that is to use a synchronous API. So anyone who wants to send an email makes a synchronous API call to the email service goes off and sends the email. But in most systems I've worked on, sending emails isn't a critical feature of the system. If an email doesn't go or an email's delayed, that's kind of okay. So here we're back in that same position again, where we've got a piece of non-critical functionality that might fail, that then might cause a cascading failure and cause my system to fail. An email has a reasonably consistent schema, doesn't it? From, to, subject, body. Email's been that way for at least as long as I can remember. So this is a really good candidate to start making asynchronous, to start prioritizing more asynchronous communication. It's non-critical, it's got a reasonably consistent schema. If it doesn't happen for a minute, an hour, it's kind of okay. So how would you actually do that? How would you actually do commands in an asynchronous way? Well, the first thing you could do, of course, is you could build your email service to start consuming that order completed event. And then the email service knows when that order completed event happens, it needs to go off and send an email with a certain subject, with a certain body. But now you've put all the logic for what email should look like, an order confirmed email, inside the email service, not inside the order service. So if the order service needs to change that email, you're back in that same position where you're stuck in the backlog of another service that you don't control. So this doesn't really work either, using pure events. And this is where asynchronous commands can be really useful. Instead of your email service exposing some kind of HTTP API, your typical REST API, it's going to expose some kind of message channel as its API. That might be a topic, that might be a queue. And that topic is going to, all the other services in your organization that need to send emails will have permissions to publish messages onto that topic directly. And they're going to publish a send email message, a command. It's not an event, it's not past tense, it's not already happened. I am asking a system to send an email. That message is still going to follow that cloud event specification. You're still going to have a defined spec. The to, the from, the body, the subject inside the data. You'll notice as well there's also a response channel property there. The response channel allows you to start to do asynchronous request response. In the event you publish, you can say, in the command you publish, you can say, actually, here's what I want you to send a response back to give me an update on how things are going. So you send that send email command. You as the order service can go off and start doing more work. You can start doing other things. That's going to be consumed by the email service. Email service is going to go off and send the email, and then going to make that call back to the response channel. So this is the way you can do asynchronous request response, asynchronous commands. In some cases, you might want to keep things synchronous. If it's an absolutely critical piece of functionality that you absolutely need to know has happened at that moment in time, taking payments as an example, maybe you do keep that bit synchronous. But it's good to have this as a pattern for these kind of ancillary pieces of functionality that aren't super important. So let's walk through this complete end-to-end flow now. Let's actually walk through how this flow is event-driven. So that submit order request comes in to your order API. Your order API does that little bit of validation, check that the order is valid, stores the data in a database, and publishes the order confirmed event. The kitchen is going to consume that order confirmed event. The kitchen is going to go off. It's going to create the order. Eventually, the kitchen is going to publish an order prepared event. The order prepared event is going to be consumed by the delivery service because the delivery service needs to go off and obviously deliver the order to people. But the order service is also going to consume that event to then go off and update the status of the order in the database so that when I come along and I'm trying to get the status of my pizza order, I know exactly that this order is now being prepared. There's one more potential problem with what we've built here. That's with this little component here. So that submit order request is going to come in. You're going to store the order in the database, and then you're going to publish the event. What happens if that event fails to publish? Now you've got the state stored in your database, but the event has never made it, so that pizza is never going to be created, which means you're going to have some very sad customers. The opposite could also happen, even more dangerous. The event could be published, but maybe the state doesn't make it to the database. Now you've got a kitchen making an order that technically doesn't even really exist. So how can you deal with this? How can you handle this? The first pattern to think about is the outbox pattern, the transactional outbox pattern. Is everyone familiar with the outbox pattern? Okay, cool. So what you do with the outbox pattern is that you're going to have two tables in your database, two different storage locations. You're going to have your actual table that's going to store the actual state, the order information, and you're going to have a separate table, an outbox table. And when you update your state in the database, you're also going to write the event that you want to publish into the outbox. And you're going to wrap all of that in a database transaction. Which means if either of them fail to happen, well, the whole transaction fails. Nothing gets stored in the database. And then you've got some secondary process that's simply working through the outbox, looking for things that haven't been sent, going off and sending them events. Now, this does mean that you're typically going to be duplicating data. The same data that's going to be in your event is typically the same data that's going to be in your database table. So you end up with some duplication. You also need to be really careful with cleanup. I've once taken a system offline because I never cleaned up the outbox table. You end up with this infinitely growing log of all the events that have been sent. Suddenly, the Windows server that was running the SQL server stopped working because there was no disk space. So you do need to make sure you've got cleanup mechanisms in place. When things have been sent after so long, you're going to want to clean them up. There's another pattern we have here, though, that can help us. The idea of change data capture. If you're using a database provider that supports change data capture, you can take the changes that happen in your database out as a stream of some kind, and then you can use that to kind of infer the events that you want to publish. Services like Amazon DynamoDB, for example, DynamoDB has a feature called DynamoDB Streams, which means you can stream out all of the changes that happen in your database. So then you're not duplicating data, you're not worrying about using up disk space, you can just react to that changes that are happening in your database, use that to publish events downstream. So excellent. There you have it. You've done it. You've taken the pizza restaurant, you've turned that from synchronous microservices into asynchronous microservices, which is fantastic for them, not so good for all of you who now have to go back to your own companies, right? Because you've just done this theoretical company and made that event-driven. So what does this mean for you? How can you get started adopting an event-driven system? And the first thing you're going to want to do is start small. Don't try to make your entire system event-driven overnight. Pick one little integration, one point of integration. You want to pick something that isn't completely critical, isn't your tier 1 service, but also something that not something that doesn't really matter. You want to pick something in the middle. And make that event-driven. Learn some lessons, get some best practices in place, get some standards in place, and then start to scale that across your organization. The other thing I always recommend to people is to add events. Regardless how you're building your system today, start publishing events when things change. If something gets written to your database, publish an event that the thing changed. Because until you've got events being published, you don't have the potential to be able to add things to handle them events. And then maybe you get to a point where you need to add a new feature, a new piece of functionality, and you think, I've got this event, fantastic. And this event has a defined schema, and I'm going to make it durable. I'm going to put a queue in front of my consumer to handle the load. And then you can slowly start to add these pieces of event-driven functionality. And remember, event-driven architecture is fundamentally a communication pattern. It's a way of modeling integrations between systems. And of course, a lot of this is the technical communication between systems. But it's also the human communication. The language, the words we use is incredibly important. And whilst software development, at least for the moment, is still a completely human endeavor, it probably helps to keep that same language in your system. And you can bring this language into your integrations, into how your systems work. Now, of course, event-driven architecture is not a silver bullet. Nothing in software ever is. It does have its trade-offs, it does have its pitfalls, but I hope if you're all going out to start building event-driven systems after you leave here, that you understand some of them pitfalls and you have patterns to help you build against that. All the slides for the talk are on that QR code there at the bottom. I've also got a whole lot of videos on my YouTube channel talking about event-driven architecture and some of the patterns. And actually, since last time I gave this talk, I actually built plant-based pizza. So if you want to take that top QR code, that will actually give you a deployable version of the application. It's all AWS, so if you're not familiar with AWS, then maybe not so useful. But look, thank you all very much for listening. I will be here for questions if anyone's got any questions. Thank you.